Hello students, how are you? I hope you are doing good. So here we are. I welcome you in this session of question discussion of AIT 6 NEET paper. So we are going to discuss some of the problems in which you might have problem or you might troubling with the concept. So we will discuss them one by one and see the concept behind them and try to understand that how the things can be possible. Okay. So let's get started with it. This is the very first question on your screen. So a person throws ball vertically upward into the air at a regular interval of time of 1 second each. The next ball is thrown when the velocity of the ball thrown earlier becomes zero. Now this line is the important. So when he throws the next ball, the other ball has achieved the maximum height. And why I'm able to say this? Because in the statement, if you see, the velocity of the earlier ball will become zero, and it is only possible when the ball achieve the maximum height. So this is a hint. Now the height to which the ball rises is, and one another hint is given is the regular interval of time between the throw is 1 second, which means in 1 second the ball will reach the maximum height and then it come back again. So time to achieve the maximum height is 1 second here. Now it is given that time is given as 1 second. So we can apply the motion of equation v is equals to u plus at because it has been thrown with some velocity. So we need to find out that initial velocity first of all. So v is equals to u minus gt. We can directly apply. V at maximum height will become 0. So u is equals to zt. U, g, t is given as 1. So it is 10 meter per second. Now S will be ut minus 1 by 2 gt square. S is equals to u we have already calculated 10 into 1 minus 1 by 2 times 10 into 1 square, which gives you S is equals to 5 meter. So this easy concept in this question. Okay, you need to understand that when it goes to the maximum height, the velocity of the ball will become 0. Now, the graph shows in the figure shows the velocity versus time t for a body. Which of the graph represent the corresponding acceleration versus time graph? Now we know that in VT graph, whatever the type of VT graph is, the VT graph, slope of VT graph gives you what? It is V by T or change in V by change in time. So change in velocity per unit change in time will result in acceleration, which means you just need to compare the slope with the given answer. Okay, so we can say that in this question, the first slope is negative because it is downward. Okay, so this slope from this point to this point, the slope is negative up to 2 junction. Let's say this is 1, this is 2. So up to point 2, this graph is being negative. Sorry, the acceleration, the slope of the VT graph will be negative, which means that if slope is negative, which means acceleration is negative. And one thing also you have to notice that the slope is constant. Slope here is constant one and negative. Constant and negative. Again, from this point 2, it will change its curvature and become positive. Okay, up to this point. This is point number 3. This is point number 4. So this will become positive. Now for this point, the slope is obviously constant, but it will become now positive. So if you see in this option, the slope here is constant. Okay, you can see that slope is constant, but one thing, this slope means acceleration. So acceleration should be constant and negative for first two half. Again, here if you will see, the acceleration is increasing, which means not a constant quantity. So this option will not work. In this option, if you will see, the acceleration is negative and constant. So it is satisfy this condition. Then again, it will become positive for this time period. At point 2, it will become positive and constant, satisfy the condition. But at this point, it will become again negative up to this point. After that, it will become negative and then again positive. But here, the graph is restricted only to this 4 point. So this cannot be the possibility. This obviously cannot be the possibility because here the acceleration is very. So only this option is remaining and it is satisfy our condition. The first is constant and negative. Then after 2.2, it will become positive and it will become positive and constant. And then again, it will drop its value to 0. Got it? So option B is the correct option. Now, two tall buildings are 30-meter apart. The speed with which a ball must be thrown horizontally from a window 150-meter above the ground in one building so that it enters a window 27.5 meter from the ground in the other building. So in this question, this is the building first of all, and this is the another building. Okay. So in this building also, there are windows and all. So the height, and they are separated with a distance of 30 meter. Okay. Now, this ball which is thrown horizontally from a window 150 meter above the ground in one building so that it enters a window of 27.5 from ground in the other building. So let's say we have dropped or we have thrown a ball at 150-meter height from this in horizontal direction, and it will cover a distance and reach to the 27.5 meter. Okay, and another building. So we need to calculate the speed with which the ball must be thrown. So let's say we consider the ball will be thrown with a velocity v. Now initially the ball is thrown horizontally, which means ux, if you talk about it, is we will consider it u, and initial vertical velocity uy is 0. But there is a gravitational acceleration in downward direction. So after some time, there must be a vertical velocity, and that is why it is going down because of the development of vertical velocity. But this horizontal velocity will remain constant because there is no acceleration in horizontal direction. All the data is given to you now. So to cover 30 meter with a speed u in horizontal direction, let's say it will take time u into t. Okay, this is equation number 1. Now, the vertical height that it has been covered is not 150 meter. 150 meter is the height of that window from the ball, from where the ball has been dropped, thrown. So it is 150 minus 27.5. So we can apply Sy is equals to u by t plus 1 by 2 times a by t square. Now, if we consider downward direction to be positive and upward direction to be negative. Why? Because we measure the Displacement also in the negative direction, in the downward direction. So it is for easiness, we will consider the downward direction to be positive. Now, it is 150 minus 27.5 is equals to uy, initially it is 0, 1 by 2 times a is g into t square. The time should be same, time must be same. To cover this horizontal range, same time will be taken to cover this vertical range. Okay, so now what we are going to do, we are going to put the value of u, put the value of t in terms of u. So here 150 minus 27, 150 minus 27.5 will become 5, 9 minus 7 will become 2, and this 4 minus 2 will become 1 and 2, and it is 120.5 meter. So 122.5 meter is equals to 1 by 2 into 10 into t square. Now you will put the value of t as 30 by u. So 122.5 is equals to 5 t square, 2 5 is 10, t square, which means 30 by u whole square, 30 by u whole square. Now 122.5 is equals to 5 into 900 divided by u square. U square will become 5 into 900 divided by 122.5. Okay, you can cancel this. 5 to ja 10, 2 will remain, 2 is you can carry forward, 5 4 ja 20, and 5 5 ja 25. So u square you can take, u will be square root of 900 divided by 24.5. Now 24.5 is very near to 25, so we can consider it to the square root of 5. So 900 ka square root will become 30, 24.5 approximately we will take it 5. So it is 5 6 ja 30. So u, the vertical, the horizontal velocity will be 6 meter per second. Okay, option B is the correct option. Now a projectile is thrown at an angle 37 degree from the vertical. The angle of elevation of the highest point of the projectile from the point of projection is. Now in this question, you need to be very careful about the statement of the question. Here, in most of the question, the angle is given from the horizontal. But here in this question, the angle of projectile is given from the vertical. So you need to take care of that. Now, so this is the scenario. This is a projectile we have thrown. This is the vertical velocity. Let's say this is the velocity. Let's say v. We will take it v. And this angle is given to you from vertical. So we will calculate this angle. It is 90 minus this angle, and 90 minus 37. It is 90 minus 37. Okay. So here it has been said the angle of elevation at the height from highest point of the projectile from the point of projection. So one vector, one line you have to draw on this side up to this. So this angle has been asked to be this angle. This is not the same angle as V. Okay. I will make a very elaborative diagram of it. This is V at an angle, let's say theta, which is given to us. And that is the angle of elevation, theta dash, that we need to calculate. Okay. So this is the H, this height is H, maximum height. And we know that at maximum height, the range would be covered as R by 2. Okay. So it's very simple. What do we need to do? We need to calculate this tan theta dash. So tan theta dash here is equals to the perpendicular over base. Perpendicular is h and base is r by 2. So it is 2h over r. Now we need to put the formula. So h we know highest point or the maximum height is u square sine square theta by 2g, and r is u square sine 2 theta by g. Okay. Now put the value 2 into u square sine square theta by 2g divided by, put the value of r, u square sine 2 theta by g. G and g will cancel out. U square and u square will cancel out. The only thing remaining is 2 sine square theta divided by sine 2 theta. So tan theta dash now is 2 sine square theta divided by sine 2 theta. We can open sine 2 theta also. 2 sine square theta divided by 2 sine theta cos theta. Now we will cancel this sine theta. 2 and 2 will also cancel. So it will become tan theta. And this is tan theta dash. Now we know that this angle of velocity is given you here. We have considered this angle. And this theta is 90 minus 37. Okay, we know that there is a famous triangle you must aware of. This angle is 37. So this length would be 3. This angle is 54 approximate 53 approximately. So this length would be 4 and it is 5. So you can apply tan 53 in this because 90 minus 37 is tan 53. So tan 53 is 1053. For that, this will become the height, this will become the base. So it will become 4 by 3. So tan theta dash is equals to 4 by 3. Now, in this situation, if we will deal with it, you have missed this. It is given as r by 2 and this is u square sine square theta by 2g. So this 2 will be cancelled out by this 2. This 2 will cancel out this 2. So there is no 2 remaining in this side. Okay. So only this 2 will be remaining for 2 sine theta and cos theta. So it will become tan theta by 2. Okay. So it is just the reversal of the number because 37 is 3 by 4. So tan theta, because theta is given from this side. Okay. So tan 37 will become, we will take tan 37. It will become 3 by 4. So this will become 3 by 8. Now theta dash is nothing but tan inverse 3 by 8. Okay. So tan inverse 3 by 8 is the correct option. Now, a block kept on a rough inclined plane as shown in the figure remains at rest up to a maximum force of 2 Newton down the inclined plane. The maximum external force up the inclined plane that does not move the block is 10 Newton. The coefficient of static junction between the block and the plane is. So try to understand what it means, what has been said in the question. So to keep the block in this line, so the block will remain at rest up to a maximum force of 2 Newton down the inclined plane. Okay. So if I draw the FBD of this block, there is a force of mg cos theta and this is the force of mg sin theta. So along with mg sin theta is trying to pull this block downward, the friction will act upward. So with this mg sine theta, 2 Newton of maximum force, 2 Newton of maximum force will be able to hold this block in this situation. Okay, which means after 2 Newton, the block will start sliding. That also means that at this 2 Newton, the friction force will be limiting friction. Okay, so we know that FL is equals to mu n. So first equation we have is FL is equals to 2 plus mg sine theta, and theta is obviously given to us. So FL is 2 plus mg by 2 because sine 30 is 1 by 2. Okay, here you can also write the value of FL, which is mu into n, and n is nothing but it is equals to mg cos theta. So mu mg cos theta 2 plus mg by 2. Now mu mg cos theta will become root 3 by 2. So it is 2 plus mg by 2. What we will do, we will take the mg common. Okay. So now mu mg root 3 mu mg by 2 minus mg by 2 is equals to 2. So in this equation, we will take mg as common. So this will become root 3 minus root 3 mu minus 1 into mg by 2 is equals to 2. Now root 3 minus root 3 mu minus 1 into mg equals to 4 by 2. We will multiply it with 2. Now this would you will consider the equation number 1. Another information that is given in the question is the coefficient of static, the maximum external force of the inclined plane that does not move the block is 10 Newton, which means at 10 Newton, when the force of 10 Newton is applied, mg sine theta is obviously acting on the downward direction. Now the friction will act in the downward direction because the block will try to move upward. So friction will oppose the relative motion, and it is obviously applied by its maximum value. So another equation we will have as mg sine theta plus FL is equals to 10. Now mg sine theta is mg by 2. FL is mu mg cos theta is equals to 10. Mg by 2 plus mu mg cos theta is root 3 by 2 is equals to 10. Now again you will take mg by 2 common. So it will become root 3 mu minus 1 divided by into mg by 2 is equals to 10. This is equation number 2. Now we will divide equation number 1 with equation number 2 on, or you can also multiply with 2 in this 10. So this will become root 3 mu minus 1 mg is equals to 20. This is equation number 2. Now dividing equation 1 and equation 2. So root 3 mu minus 1 mg divided by root 3 mu plus 1 mg is equals to 4 by 20. Mg and mg will cancel out. 4 5 is 20, so it will become 1 by 5. Now you will multiply this. So it is 5 root 3 mu minus 5 is equals to root 3 mu plus 1. You take this 5 this side and take this root 3 mu on the LHS. So 5 root 3 mu minus root 3 mu is equals to 6. 5 root 3 mu minus root 3 will become 4 root 3 mu is equals to 6. Now 2 2 ja 4, 2 3 ja 6. Now you will cancel this root 3 by this. So it will become root 3. So mu here is root 3 by 2. Okay. Now the root 3 by 2 is the correct option. Now this is a very tricky question. So acceleration of the block A in the situation shown in figure is A. Okay. Acceleration of block B is to find out. So acceleration of this block is given you as A, and we will consider it upward, and this side will go down with same acceleration because the string is C. Okay, the same string we have used, so acceleration will not change, and also the pulley is also frictionless, so acceleration will not change. So this side will also have acceleration. But if you talk about this end is fixed with the fixed pulley. So this side has an acceleration 0. Okay. And the pulley, let's say the acceleration of the pulley is AP. And the same acceleration with the block B, because block B is directly connected to the pulley. So we know in case of movable pulley, we know the relation that 2 times of acceleration of pulley is equals to A1 plus A2. And here A1 and A2 will put with sign. Now A1 is the acceleration of this limb and A2 is the acceleration of this limb. This limb is fixed with the fixed pulley, so it has an acceleration 0. To AP, A1 is moving downward, so we will consider downward direction to be negative, upward direction to be positive. Okay, so acceleration of pulley. Now A1 is moving down, so it is minus A. Now acceleration of pulley will become minus A by 2. Okay, so the pulley is also moving down with an acceleration minus A by 2. So option C is the correct option. Now, sand drops falls vertically at the rate of 2 kg per second onto a conveyor belt moving horizontally with the velocity of 0.2 meter per second. Then the extra force needed to keep the belt moving, because as the sand drop will falling, they are exerting pressure on the belt. So we need to extra force to conquer that pressure and to keep moving the belt. Now here the mass flow rate is given to you, which means mass you can treat as variable mass. So it is 2 kilogram per second. For the definition of force, which is nothing but dp by dt, change of momentum per unit time. We know that change of momentum is given by mv. Here, in the most equation, we will take m as constant out and dv by dt is the acceleration. But here, the belt is moving horizontally with a velocity of 0.2 meter per second, which is a constant velocity. Okay. But here the mass is variable. So we will have to differentiate mass also. So you can take that dm by dt into v plus dv by dt into m. We know that there is no acceleration. So this dv by dt m will cancel out. Only this dm by dt into v will remain. Dm by dt is nothing but 2 kilogram per second. Multiply with the velocity, which is 0.2. So it will become 0.4 meter, sorry, 0.4 Newton. So option I is the correct option. So that much excessive force we need to rotate that conveyor belt. Now, a pump of power P is used to pump water in a certain pipe at a certain rate. Okay. The pump twice as much water through the same pipe in the same time. To pump twice as much water through the same pipe in the same time, the power of the pump must be increased too. Okay. So there is a pump which is supplying the water or which is pumping the water in a particular pipe. And let's say this is the pipe. Okay. Now, given that we have considered a pipe to move in this pipe at a distance of x. Okay. We need to move with a certain velocity. Got it? So if I talk about that how much the volume will flow into this, okay, we need to calculate the volume flow rate in this question, because with the help of volume flow rate we are able to calculate the kinetic energy of this. Okay, and if we are able to calculate the rate of kinetic energy, it will directly give us to the power. So the purpose here is to calculate the volume flow rate, which automatically gives us the, we will use the kinetic energy flow rate. So kinetic energy flow rate is nothing but power. So here, if the area of this pipe, let's say A, okay, and pump is delivering a velocity, power with the pump will deliver the water with a velocity V. Okay, we know that power is nothing but force into velocity. Got it? Now, if the water jacket inside it move a distance x, move a distance delta x, let's say here this water has been displaced by a distance delta x. So we can calculate the volume of it. Volume of it will become delta x, which is the length of this small cylinder, multiplied by the area. So volume we can say it is delta x into area. Now, if we divide it by time t with time t, so this will become volume flow rate v dot, and this delta x by delta t is nothing but the velocity. So we will take it as v, small v. So here small v here is the speed and capital V is the volume flow rate. Volume flow rate. Okay. So V dash here is V into A. This is the volume flow rate of this liquid. Okay. Now, if I talk about that how much mass has been covered by this, because in kinetic energy, we know that kinetic energy is nothing but 1 by 2 times mv square. Okay. Got it? Now, mass is nothing but 1 by 2 times mass is nothing but density of this liquid multiplied by the volume. Okay. Now, it is V square. This V and this small v is different. So if I talk about, if I differentiate it with time t, the kinetic energy per second will directly give you the power. So kinetic energy per second is power is equals to 1 by 2 times this volume by time will become volume flow rate, which is given by velocity into area. So it is rho A into velocity square. So the power is 1 by 2 times rho A V cube. So from here we can say that power is directly proportional to V cube. So to pump twice as much water through the same pipe, so we need to move with the faster velocity, because we know that mass flow rate is also dependent on the volume flow rate. Okay, and volume flow rate is nothing but the velocity. So it is dependent on the velocity, and power is directly proportional to the cube of the velocity. So to double the flow rate, we must double the velocity or speed. Okay. So speed from V to we have to move it to V. So the power P dash will become 2 ka cube will become 2 cube, or you can say it is P dash will become 2V cube. So P dash is nothing but equals to 8P. Okay. Because 2 cube is 8. So 8 times the power we need to be delivered. Option C is the correct option. Now, the next question is, a circular plate of radius a by 2 is kept in contact with a square plate of side a as shown. The density and thickness are same everywhere. An important point. The center of mass of the composite system will be. Now, density of this circular plate and this square is same, and also the thickness is also same. Okay. So we know that the center of mass is nothing but m1r1 plus m2r2 divided by m1 plus m2. Okay. We will consider the origin at the center of the circular plate. Okay. And we will consider it to be a point mass which is located at the center. So its center of mass is the origin itself. So R1 will become 0. But this much is the distance from the origin, the center of mass of this object. So this distance is a by 2, which is the radius, plus this distance is also a by 2, half of this. So this a by 2 plus a by 2 will become a. Okay. So we will put the value m1 into 0 plus m2 into a by 2. Sorry, m2 into a divided by m1 plus m2. Now, our center of mass is nothing but m2 into a divided by m1 plus m2. Now, m2 and m1 we need to find with the, we can say that m2 is nothing but density of that particular material into volume. Now we know that volume we can also calculate by area into thickness of that particular element. So for m2 it is a2 into t2 and rho 2. For m1 it is rho 1 into a1 into t1. But in the question that is given there, the density rho 1 is equals to rho 2 and thickness t1 is equals to t2. So put the value. M2 you will put as rho 1 equals to rho 2 into rho, t1 is equals to t2 equals to t we will consider. So rho into a1, sorry, a2 into small a divided by m1, put the value of m1 which is rho a1 t plus rho a2 t. So we can cancel out also m2, the value of m2 will be rho a2 into t. We will cancel out the rho t from both numerator and denominator. So this will become a2 into a divided by a1 plus a2. Now it is very simple to calculate the area of this. A2 is the area of square, so it will become a square into a. A1 is the area of this. So in terms of diameter, it is pi by 4 into diameter square. So diameter is nothing but a. So pi by 4 a square plus a2, the area of square is square. This will become AQ divided by pi plus 1 into AQ, A square. This will cancel the 2 power of it. It will become 4 upon 3.14 is the value of pi plus 1. So 4.14 into A. So it will come out as 0.656 as A, which is it is slightly enter in the square. Okay, because at 50% it is at the interface. Okay, we cannot say at the interface, it is not inside the sphere also, sorry, the circular plate also, and not inside the square, but it is 0.56, which is slightly greater than 50%. So it is inside the square plate. Option B is the correct one. Now, a thin wire of length L and uniform linear mass density rho is bent into a circular loop with center O as shown. The moment of inertia of the loop about axis xx dash is. Now, in this question, we need to apply the parallel axis theorem and perpendicular axis theorem. Simply, you are thinking that we can apply it, but you don't know about the what is the moment of inertia about this axis, the diametral axis. So we can apply the perpendicular axis theorem. So firstly, perpendicular axis theorem. Perpendicular axis theorem says that Iz is equals to Ix plus Iy. So in this case, Iz is outside and Ix is this, Iy is this. We know that same moment of inertia about x-axis and y-axis will be there because both are the diametral axis. So Iz we can put as 2 into I because Ix in this case is equals to Iy, which is equals to I. Now Iz we know the moment of inertia about this thin wire, which is in the shape of ring, which is rotated about this axis passing through its center. So the moment of inertia in this case will be mr square. So we will put this value mr square is equals to 2 times of I. I here will become mr square by 2, equation number 1. Now parallel axis theorem, parallel axis theorem. So we need to calculate the inertia about x dash axis, xx dash. So inertia about xx dash is nothing but inertia about center of mass, okay, which is this axis. We will take the diametral axis, x ICOM plus, which is nothing but I, plus mass, which is let's say m, and the perpendicular distance between this, which is nothing but r. Okay, we will consider the radius is r. It is r square. Now put the value I here. So I x x dash will become mr square by 2 plus mr square. So it is nothing but 3 by 2 times mr square. Now, in the question, length is given to you and mass density rho is given to you. Okay. So we'll calculate the mass and radius in terms of this length and mass density. So we know that if the length of wire is L and it is bent into a ring, so the circumference of that circle will exactly equals to the length of the rod. So we can say that 2 pi r is equals to L. From that r we can put as L upon 2 pi. Put the value 3 by 2 times m into r square will become L square upon 4 pi square. Now mass here Mass we can put at rho, which is the linear mass density, into length. Linear mass density is always equals to mass per unit length. Okay, so put the value. So we will have 3 by 2 times rho. You put the rho L will become L cube here. Rho L cube into 8 pi square. Okay, so 3 rho L is cube divided by 8 pi square, the correct option. Now, two wires are made of same material and have the same volume. Same volume. The first wire has cross-sectional area A and second wire has cross-sectional area 3A. So this is the first wire, let's say, and this is the second wire. Now, obviously, if the volume of this and volume of this V1 is equals to V2, so volume is nothing but length into area. L1 into A1 is equals to L2 into A2. Now, there is nothing said to be about the length, but if the volume is constant and the area of this wire is A, L1 into A and L2 into 3. So we can say that, and if I consider the length of this will be L, so L1 we put at L is equals to L2 into 3. So length of the another wire will be the 1 by 3rd of the initial length. Now, if the length of the first wire is increased by delta L on applying a force F, so how much force do we need to stretch the second wire by the same amount? Same, which means we have to elongate it by delta L. And same, we need to do it with this delta L. So we know the formula that delta is nothing but F force applied into original length divided by Young's modulus of elasticity into area, FL over YA. In the first case, the force F has been applied. The length L is L, Y is Y, and area is. But in the second case, we need to maintain the delta L same. So here, F dash we need because length and area has been changed. So length will become L2. L2 is nothing but L by 3. I have taken it the downside. Into Y, I have put the Y same because same material is been there. And Y is the property of material. Now area is thrice of it. So delta L here is F dash into L divided by 9 times Y into A. You need to put the value of delta L from this equation, which is FL over YA. You can cut this L and this pi A. So from here you can say that F dash is nothing but 9 times of option C is the correct option. Okay. The more importance you have to give in this question, the statement same material and same volume. Okay. Now, in this question, one end of a U-tube of uniform bore means area. So the hole that we have drilled, area A containing mercury is connected to a suction pipe pump. Because of it, the level of the liquid of density rho falls in one limb, and when the pump is removed, the restoring force in the other limb. So in this limb, we have provided a suction pipe here. The suction pipe, what will do? Suction pipe will suck the air inside it. And if we are sucking the air, we are creating the vacuum. So mercury will immediately fill that vacuum so that it will rise up. Okay. Here you will see the distance up to which, the height up to which the mercury has been risen is 2x. X plus x. Now, according to Pascal's law, the pressure at this point will be same. Let's say this point is A, this point is B. Okay. So the restoring force is nothing but the force that is applied by this amount of or this weight of the mercury. Got it? Now what we are going to do, we are going to calculate the pressure, and with the help of pressure we will calculate the force. So PA is equals to PB. PA here is only P atmospheric is equals to PB, or let's say PA, we will take at PA. PB is nothing but P atmospheric plus rho G, rho of mercury into gravitational acceleration multiplied by the height. Okay, so this much of pressure we need. Got it? So pressure at B, PB will be rho G times 2x if I do not consider the atmospheric pressure at all. Okay, so pressure at A is also equated to P atmospheric plus rho G 2x. Now we know that at this point B, the pressure which is acting is P rho into G into 2x. This is the pressure at B. If I just neglect the atmospheric pressure. So PB we can write, we know that force is nothing but pressure into area. So FB, which is the restoring force, will be PB into area. Area of the limb is given as A. So P is rho into G into 2x into area. We can write it as 2 rho Gx into A. This is the restoring force that mercury would apply on this side. Okay, so rho G 2x is the correct option. Now, two soap bubble with radii 3 cm and 4 cm came in contact. Their common surface has a radius of curvature. When these two soap bubble came in contact, okay, so they will make an interface like this. Okay, it has a radius of curvature other than both of the sphere, and they have radius of sphere as, let's say this is 3 cm and this is 4 cm. Okay, so we need to find the radius of curvature of this curve at the contact line. So we know that excess pressure in the soap bubble, it has two layer, or we can say the two surfaces it has. So the excess pressure, let's say this is, we will consider it as 1, and this we will consider it 2. Excess pressure in 1, P1 is nothing but 40 by R1. P2 is nothing but 40 upon R2, because same soap bubble hai, so tension we have taken same. Now R1 and R2 are different. R2, we know that R1 is greater than R2. So if R1 is greater, so this value will be lower. So P1 is less than P2, which means this sphere, the smaller sphere, will exert more pressure on the other soap bubble, the soap bubble which have higher radius. Okay, so P2 minus P1, if I calculate, P2 minus P1 is equals to 40 upon R2 minus 40 upon R1. Now, the same pressure difference, this same pressure difference is at the junction of it, at the contact surface. So we will consider this contact to be a bubble which having the excess pressure of P2 minus P1. So we will consider it as P. P is nothing but 40 upon, let's say, capital R, because R is the radius of this bubble. This P is nothing but the pressure pressure difference by these two bubbles. That is why this interface has been developed. So this 40 upon R is equals to 40 into 1 upon R2 minus 1 upon R1. So 40 and 40 will cancel out. 1 upon R will become R1 minus R2 divided by R1 R2. Now R is nothing but R1 R2 divided by R1 minus R2. R1 is 3 centimeter. You can consider R1 is greater than R2. So R1 is, we have considered 4. 4 into 3 divided by 4 minus 3. So 4 into 3 is 12 centimeter. 4 minus 3 is 1. The radius of the interface or the curvature will become 12 centimeter. Now, in this question, there are two circular small holes on the opposite side of a tank containing a liquid. The ratio of radius of circular hole is 1:2. The tank is open at the top, and if container experiences net zero force, then ratio of the distance from the top of these two holes is. So here is the situation. This is the container. Let's say this is the container we have, and we have two holes in this. One is here, and one is somehow greater, because the larger hole have the larger area and the larger flow rate it will have. So we will put it on higher side so that it will have lower value of pressure, because if we put this on the bottom side, then higher pressure and higher is the area, so it will result in more force. Got it? So that is why we have placed this one in this side. So let's say, just a second. So here we have this hole, here we have this hole. Height of this from the surface of the liquid, this is the liquid filled in this block, in this container. The height of this will become h1, and it has a height from here is h2. Now we know that pressure at this point will be rho g h1, and pressure at this point will be rho g h2. So if I consider this as point 2, so P2 will become rho g h2, and P1 will become rho g h1. Now we know that force, if I want to write, F2 is nothing but P2 into A2, and F1 is nothing but P1 into A1. Now F2 we will put at P2, the value of P2 we will put rho g h2. Okay. Now A2 is A2, F1 is P1, put the value of P1 is rho g h1 A1. Now this is given in the question that container experiences net zero force, which means F1 is equals to F2. F1 here is equals to F2. Now, F1 is equals to H2, put that value. Rho G H2A2 is equals to rho G H1A1. Rho G and rho G will cancel out. So, H2A2 is equals to H1A1. H2 by H1 is equals to A1 by A2. Now, A1 is nothing but pi R1 square. The holes are circular, and it is pi R2 square. And we know that this, if the radius of it will be R2 and this will be R1. So 1 by 2, yani ki R2 by R1 is given to as 1 by 2. So here pi and pi will cancel out. R1 by R2 whole square. But in this question, R2 by R1 is given. So you need to reverse it. H2 by H1 is equals to 2 square, which is 4 is to 1. So H2 is to H1 is 4 is to 1. So this is the ratio of height. Okay, so 4 is to 1 is the correct option. Now, two gases have same initial pressure, volume and temperature. They expand to same final volume, one adiabatically and other isothermally. Then, so here are two processes from 1 to 2 and 1 to 3. 1 to 2 is the isothermal process and 1 to 3 is the adiabatic one. Now, if I correct the option 1, the final temperature is greater for the isothermal process. Okay, we will check one by one all the option. Now, initially they have same temperature. Initial pressure, volume and temperature are same. Let's say T1. T naught is the initial temperature for both the gases. Now, one gas has expand isothermally and one gas has expand adiabatically. Now, we know that in isothermal expansion, the temperature remain constant. So at point 2, the temperature is remain constant as T naught for isothermally expansion. But for adiabatic expansion, the temperature is not constant. And for the expansion, the temperature will drop. So it has lower value than T naught. So here the temperature is T, which is less than T naught because it is adiabatically expanding. And on expansion, the gas will the gas temperature will decrease. So finally, it has lesser temperature than isothermally expanded gas. So the final temperature is greater for isothermal process. So this option is correct. Now, the final pressure is greater for adiabatic process. Now we know that the pressure graph is given to you. If you compare the height, the pressure for 2, which means isothermal is greater than pressure for 1, which is adiabatic. So this option is incorrect. Final pressure of isothermal is greater than the adiabatic. Now, the work done by the gas is greater for adiabatic process. Now, work done is given by P into dV, the integration of PdV, and which is nothing but the area under PV curve. If you calculate the area by 1, 1, 2 line, so it is obviously greater than the area of 1, 3. So which means work done in isothermal is greater than work done in adiabatic. Okay. So this option is also incorrect. Only option A is the correct option. Now, consider a spherical shell of radius r at temperature T. The black body radiation inside it can be considered as an ideal gas of photon with internal energy per unit volume is U is equals to U by V, directly proportional to temperature raised to the power 4. And pressure P is equals to 1 by 3 times U by V. If the shell now undergoes an adiabatic expansion, then relation between T and R, where R is the radius of the spherical shell. So in the question, what is given to you is P is equals to 1 by 3 times of U by V. If I consider the energy density, which is U by V, is directly proportional to temperature raised to the power 4. So we can equate it, we can remove the proportionality sign. So U by V will become, let's say, some constant K T raised to the power 4. We will put this value in this equation. So pressure will become 1 by 3 times Kt raised to the power 4. This is equation number 1. Now, it is given in the question, this is the ideal gas of photon. So we can apply the ideal gas equation, which is PV is equals to mu RT. Okay. This R I will take as R dash because it is the universal gas constant. So that for you to not to confuse with this radius, I have considered it R dash. Okay. Now pressure here is equals to, we can say that mu R dash divided by V into T. pressure, put the value of pressure, which is 1 by 3 times kT raised to the power 4. Mu r dash T divided by, you can cancel this temperature with this. So this will become 1 by 3 times kT cube is equals to mu r dash. Now volume of a spherical shell will be given by 4 by 3 times pi r cube. So from this 1 by 3 k mu r dash 4 by 3 pi all are constant. So you can say that T cube is directly proportional to 1 by r cube, which means T is directly proportional to 1 by, option A is the correct option. The last question of this session, the length of a cylinder increased by 3% due to thermal expansion. Its base area will be increased by. Now, in this question, a cylinder is given to you whose length has been increased by 3% due to thermal expansion. So we know that when length expand by thermally, so it will be given by L naught into 1 plus alpha into delta T. Okay. The radius, if I talk about, if the radius is expanding, so same expression we are going to use R naught 1 plus alpha into delta T. So we can see that L is directly proportional to R. Okay. So here length of the cylinder is increased by 3%. So delta L by L into 100 is 3. Now we need to calculate the base area expansion. The base area will increase by. So we know that base area, or we will take it as A. Base area is nothing but pi r square. Area, if we take the change of it, so delta A by A, it will follow the same property as logarithmic. So this pi will be removed, which is a constant, and 2 will come in front of the r. It is 2 delta r by r. Now from this relation, you can replace this r as L. So this delta r by r is nothing but delta L by L. So 2 into 3 delta L by L into 100, multiply it by 100, multiply it by 100. So it is 3. Delta L by L into 100 is 3. So delta A upon A into 100, which is the percentage error or percentage expansion in the base area, as given by 2 into 3, which is 6. So we can say that base area has been increased by 6%. Okay. So I hope you will find this solution to be helpful. Okay. All the question that might have a doubt I have discussed. If anyone left, please try to reach us. Okay. So thank you so much. Bye bye. Take care of yourself and please do study. Thank you.